surface areas and volumes. We are on the exercise 13.1. Question number 4. So question number 4 says a cubical block of side 7 centimeter is surmounted by a hemisphere. What is the greatest diameter of the hemisphere can have, and find the surface area of the solid. So we have to find out the greatest diameter as well as the surface area of the solid. So let's put the data and the diagram. So let this be my cubical block. Okay, so this is my cubical block, and hemisphere is surmounted on this. So my hemisphere will be like this. So can you see that I can't put it along the diagonal of the surface of cuboid, right? It is I can put only along the width, right? The width of the any side, because all sides are equal, so I can just put it on this thing. So that way I can see that my surface area of the like largest diameter, right? Largest diameter. So I can just put this along the surface, correct? So my diameter now, my diameter, they're asking the greatest diameter will can be equal to only the width of the cube, right? Because if I put it along the diagonal, that is one more way of putting it, but then my surface will come out if the diameter is the diagonal of that, so that will be equal to. So my largest greatest diameter of this sphere hemisphere can be equal to 7 centimeter, right? That is because this we are given with the side of 7 centimeter, this is 7 centimeter, and even this is 7 centimeter. So I can have the diameter as 1 equal to one side of the cube. So that part is clear, and we can also see that if I see it from the top, so this circular region will be covered and I can see only the shaded part from the top, right? So surface area, I have to find out the faces which I can see, right? So now if I have to find the surface area of the solid, so I have to find out the surface area. So I have answered my first question, the diameter will be equal to 7 centimeter, the greatest diameter which this hemisphere can have. Now surface area of solid, so surface area of solid will be equal to C, because on the top I can see only the shaded part I have shown in this figure, and circular part I can see. So I can say that I can surface area will be equal to surface area, total surface area, right? So total surface area of cube, surface area of cube, but I have to subtract this because on the top I can't see. So area of circular region, area of circular region, I have to subtract this, and I have to add the curved surface area of hemisphere, right? So curved surface area of hemisphere I have to add. So this will be my total surface area of the solid. Okay, now I can put down in the formula. So surface area of cube is 6 into a square or side square minus pi r square. So pi r square is the area plus curved surface area of hemisphere. So that is equal to 2 pi r square. Okay, now I can consolidate my formula. So minus pi r square and 2 pi r square, and radius of the circular region and the hemisphere is same. So I can write down here pi r square only, because this minus pi r square, this is plus 2. So I am doing arithmetically. Okay, now what is the radius of the hemisphere? So radius will be equal to 7 by 2, right? So this radius is equal to 7 by 2 centimeter. Okay, now 6 into side is 7 into 7 plus 22 by 7 into 7 by 2 into 7 by 2. So now this is this 7 gone, this is equal to 11. Now this is equal to 6 into 49 plus 77 by 2. So now 6 nines are 54, 6 fours 24 and 29 plus, I'll just divide this. So 2 3s are 6, 2 8 are 16.5. Okay, so this comes out to be decimal point here, 8 and 4 12, 1 carry, so 13 332.5 centimeter square. So my answer, I can write down that they had asked total surface area, right? The surface area of solid. So answer, you can keep it here also, the surface area of solid is equal to 332.5 centimeter square. Come to question number 5. So question number 5 says a hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. So there is a cube. Okay, so this is my cube, and that will have this will be my hemispherical is cut out from that. So this will be my hemispherical cutout. So in the previous question we had a hemisphere on the top of the cube, right, on one surface. So definitely we know that this curved surface area will not be included in the 6 surfaces of the cube when we are doing the 6 surfaces of the cube, right? Or if we include that, then we have to subtract this circular part, because this has been included, it has been depressed, and then it has the area, surface area will be included in the curved surface area of the hemisphere. So now suppose if I have to find the surface area of the solid, right? So surface area of the remaining solid, will be equal to surface areas. I can include all the 6 faces of cube. So 6 surface area of cube plus surface area of hemisphere, curved surface area of hemisphere, but then this has to be subtracted, the circular part. So I can say that area of the subtracted by area of circular region. Okay, so now we know that diameter is equal to L, and edge of the or side of the cube is also equal to L. Okay, so surface area of the cube formula now I'll write down. So surface area of the cube will be equal to 6 side square plus 2. This curved surface area of hemisphere is how much? 2 pi r square, right? Then area of circular region will be equal to pi r square. Okay, so now 6 into side is L, so L square plus 2 pi. I'll keep it in the form of pi only because L is also in the form of L. It's in the form of variable. Dimensions are not given in numbers, so we'll just keep it like that. So now diameter is L, so my radius will become L by 2. So L by 2 whole square minus pi, and again L by 2 whole square. Okay, so now this becomes 6L square plus 2 pi L by L square by 4 minus pi L square by 4. Okay, so now this becomes 6L square. This is 2 pi L square by 4. This is 1 pi L square by 4. So this I can write down as how much? Tell me. 1 plus 1, because this is 2 and this is 1. So I can write down as pi L square by 4. Okay, now I can take the LCM, or I can take L square common. So that's any way it is fine. So L square by, I can take common and I can take this LCM as 4 simultaneously. So this becomes 24, and this becomes plus then pi, right? So now this becomes L square by 4, 24 plus pi. That will be my answer. So I don't have to put 22 by 7 because L is on itself and variable. So I can just solve it like that. Point 1, question number 6. So question number 6 says, medicine capsule is in the shape of a cylinder with 2 hemispheres stuck to each of its ends, and a diagram is given. The length of the entire capsule is 14 millimeter and the diameter of the capsule is 5 millimeter. Find its surface area. So we have to find the surface area of the capsule. So first let's draw the diagram. So diagram says that this is in the form of capsule, and these are 2 hemispherical end, and then we have a cylinder in the center. Then this diameter is 5 millimeter. So diameter of hemisphere is equal to diameter of cylinder. So both diameters are same. So I can say diameter is equal to 5 millimeter. So I can say radius is equal to 5 by 2 millimeter. Okay, I can keep it like that, or I can write down as 2.5 also. So my this is 2.5. Again same here, it will be 2.5, and total is 14 millimeter, total length of the capsule. So 2.5 and 2.5 is subtracted from these two sides. So because this is 2.5, this is 2.5. So from here to here I'll have 14.5 minus 5 millimeter. So 9 millimeter is the height of cylinder. Height of cylinder is equal to 9 millimeter. Okay, so now radius for both is same. So these things only, dimensions only we need to calculate, I think. Okay, let's go. So now surface area of, total surface area we can say, or surface area of capsule. Surface area of capsule will be equal to curved surface area of hemisphere, or I can hemisphere into 2, correct, because there are 2 hemispheres, or I can say one sphere, that also I could write. So anyway you can write down, it will come out to be same, plus curved surface area of cylinder. So I have to add these 2 surface areas. So curved surface area of hemisphere is 2 pi r square into 2. So it gives the area or curved surface area of one sphere, plus curved surface area of cylinder is 2 pi r h. Now radius is same for both of them and 2 pi r is same, so I can take 2 pi r common in these two. So what is left here? 2r plus h is left, right? So now let's substitute the values. So substituting the values are 2 into 22 by 7, radius is equal to 5 by 2 I can write down, or 2.5, anything is fine. So 2 into 5 by 2 plus height is 9. So that goes on. Now we have this 2 gets cancelled. So this is equal to 110 by 7 into this gets cancelled, 9 and 5 14. So now 7 ones are 7 twos are 14. So this comes out to be 220 millimeter square. We just have to always write the units. Units are very important, otherwise 220 is what? 220 dozen, 220 people, 220 anything, right? So we have to write down the dimensions, and so this numerical value plus unit, right? Always this is very important, so we need to write on that.